Good afternoon and welcome to Digital Roundtable. Andre Cavallo is out solving the world problems, so I'm going to host today along with Llewellyn King, and we have a great guest today. We have Clint Thurmon, who's Vice President of Transmission at Ferreira Power South, and I want to welcome you to the greatest podcast in America that's dedicated to the kind of things that keep the lights on. There's a lot of things going on in America, as we know, Clint. We have a lot of stuff going on politically, but we like to concentrate on the great stuff that makes America great and the world great, that is electric power.
Yes, sir.
As you know, Clint, as we move forward in this great experiment of ours that's called human behavior, if you will, we will need power. Usually I sing a little song, so I'm going to sing a little song right here to get us going, and it's a lesson too late for the learning, made of sand, and are you going away with no word of farewell? Will there be not a trace left behind? Now I could have loved you better. I didn't mean to be unkind. What's the last thing on my mind? So good afternoon, Llewellyn. How are you doing?
Very well, thank you.
Well, Llewellyn, it's a great day in Austin, Texas. Why don't you tell us what's going on in your world in the great Northeast?
Well, we're all dealing with the first reduction in growth in first quarter, which has been quite shocking. But the sun is shining. It looks as though summer is going to happen. So that sort of counters the bad political and economic news. In my world, I'm fascinated by what happened in Spain and Portugal with the huge blackout. And there's a lot of speculation as to what might have caused it. So I'm interested to hear what Clint's speculation might be. The general feeling that people I talk to is it could have been a loss of rotational inertia because the difficulty that renewable power has with inertia, and there may not have been enough corresponding artificial inertia introduced into the system to maintain frequency. So I want to ask Clint, what do you think happened?
So the best that I can tell right now, and I haven't been staying 100% on top of it now that I'm only in the States, but from what I understand, it was a wave problem. It was the actual sine wave that we all know that bounces through. They, the regulators, capacitors that they had on those substations were not able to correct the wave, and which then sent, of course, a signal through, which created crashes. Outside of that, I asked just the simple questions of what do we believe? And he said, well, more reactors and or getting a better handle on what's going on. So I think more will come, but that's to my limited knowledge on it right now.
Yeah, let me properly introduce Clint. Clint oversees the operations and management of turnkey, construct only, EPC, storm, and maintenance services for non-union transmission line projects in the United States. And he has more than 20 years of experience in high voltage construction with multiple certifications and trainings in safety and health. So it's good to have you on the program because what you do, Clint, is at the very center of our concerns. Now, when we say our concerns, we understand that this is a subject that we would like to have your opinion on. We just haven't talked much about electricity over the last, 60 or 70 years, or maybe longer. And Llewellyn is like I am. When we wanted to come on, it better be there. So we're just interested in your perceptions. Where do you think we're going the technologies that's involved in where we are, how do we make sure that there's economic viability in the future? Because Clint, as you know better than I do, I think that electricity should be tied to economic development. That is, I'm in Austin, Texas, and as the great state of Texas invite companies to come here, they must be able to plug in. And the question is, are we going to a Pearl Harbor vis-a-vis electricity? So as Llewellyn asked, what's your thoughts on that, Clint?
Also, I mean, I myself, I started in '98 on a shovel. So I learned from the ground up how to build these substations, transmission lines is where I started. As I moved through more of the management and learned to start running the projects is when I started actually getting into understanding generation, getting into forecasting, meeting people like ourselves, and getting on a few of the boards of IEEE so that I could better understand what we were going for and going forward with. The main struggles that I still see today are going to be the labor shortages that come with what the demands are. We can continue to grow, and we've had record number of growths for years now. But the problem that we still run into is that you can pump so much money into this system, but you could still only produce about a 10% growth a year. And what people are not understanding is that it's not a money problem. It's not even a technology problem. It's a manpower problem. You can only build so many projects a year because they're all, our finite resource in the United States is linemen. It's not dollars. I promise you, we print money fast enough around here. It's but when you've got clients that are demanding 21 through 23 is a prime example of what I'm talking about. So you had the administration pumped in a lot of cash right after COVID. And it was, you can call it Build Back Better or whatever slogans everyone was slapping on things. But you had literally billions of dollars dumped into projects that instantly became viable. And it was like, okay, this project makes sense. Now this project can move forward. And they weren't moving forward. And granted, a lot of it, we were pointing our fingers back at procurement. Our lead times doubled and sometimes tripled. But in reality, even if you would have given me all the breakers and all of the transformers that I was asking for at the time, I still am limited by how many men and women that I've got on the ground. And every construction company like ourselves has that same limitation. We constantly are stealing resources back and forth. People don't realize is that it takes 4 years at minimum to make alignment. And it takes a lineman to do a lot of this work. You know, you can limp along with some of these, especially solar farms or wind farms. A lot of those projects are more civil related than they are actually electrically because of the roads you have to build, the infrastructure you got to build, the pilings you have to put in. So the electrical portions of those projects is limited. So you can make a lot of headway without the technical expertise, but you will hit a limit that now you need those linemen, now you need those technicians, and people were bottlenecking projects to the point to where, hey, we usually do 10 projects for simple math a year. We've got the funding to do 15 this time, so we're going to do 15. No, you did 11. Well, why do we only do 11? Well, because we can only stretch our labor force to a certain point before they become inadequate or they become ineffective. And that became the obvious piece to it. And what I think those 3 years proved to everyone is that you could dump as much money in as you want. You're still only going to get so much growth, period.
This is
Go ahead. I'm sorry. Go ahead.
yeah, this is very interesting because when I talk to utilities about impediments to growth, they do not mention labor. But when I talk to architect engineers or to anyone like that, labor is central. 30 years ago, I think I gave a talk to the trade association for people who serve utilities. And I asked before I gave my talk what's on their minds, and the answer was labor. So there seems to be this need. Now, some utilities have acknowledged a shortage of linemen, etc. I know Detroit Edison, I think it is, has a program of training prisoners,
Right.
non-violent prisoners who might. It's always seemed to me that it looked like a rather good job with a lot of esprit, a lot of security, and fairly good remuneration. But it is astounding to me that we continue to have a shortage, and I don't see a sort of cohesive recruitment and training program across the industry. Some years ago, I started what has become an annual celebration of linemen. It was taken over by the Edison Electric Institute, but I founded it when I was publishing the Energy Daily. And I've been trying to take an interest in linemen and women now, and some of them are women, but we use it in a generic way. This is something strange here, that we have this need, and it hasn't been solved or addressed with a sort of national drive. I mean, for example, should we be recruiting outside of the US? Should we have special visas to bring people in to become linemen in the US? We do it for doctors, we do it for nurses, we do it for farm workers. Maybe we should do it for electric utilities.
So in the late 80s and mid 90s, they actually did that out of the Philippines. They pulled in lots of labor. The administrations changed and the visa program was changed. And we had hundreds of thousands that were shipped back home. We've actually made that conversation, tried to make it relevant again a few times with no success whatsoever. But I think one of the key parts of what you're saying is that, so for example, when I started in '98, there was a 60% pass rate to get through your apprenticeship program. The Department of Labor did a study in 2018 where they actually broke down all the statistics that anyone can go back and find. But what they were saying is that at that point in 2018, the attrition rate or the success rate of getting through a 4-year apprenticeship was below 30%. And that the amount of people going into the program was down by half. So you've got a compounding problem. You've got half the amount of people who want to go be linemen, and then instead of a 60% passing rate, you've got a less than 30% passing rate. So again, it's a compounding problem that there's not an easy solution for, especially when you got an education system that tells kids if you don't go have a 4-year degree, you have no future. Give them a skill, give them a craft, put them in an apprenticeship out here with us. You end up with no debt, and you're making more money than your teachers who said you couldn't.
Yeah,
almost
that's
right
a
out of
good
the
point,
gate.
Clint. It reminds me of Glenn Campbell's Wichita Lineman. I don't know if you're old enough to remember that great song. I am a lineman for the county. Well, we really celebrated that. But the other thing is that on the labor stuff, we always talk about academia, government, and industry, and we never include labor.
Right.
Yeah, because I'm working with a project where we include labor, right? But what I want to ask you is that in addition to the labor stuff, if you look at the controls of how we control electricity now, and if you look at those controls, it's the same controls we had back in 1925, right? We still have people leveling, but it's changed some, not completely,
Yes.
right? We have some automated stuff, but for the most part, we still have people. What about AI? Would that have, do we need to consider the importance of AI as we expand and add to the labor component?
100%. So, and you're 100% right. We are using smarter technology, smarter relays. We can mission the communications and the RTUs inside of the substations a lot better nowadays. The communication delays between stations is almost non-existent nowadays, but you still have a manual piece to a lot of that. You still have not ultimate control all over those. Now, of course, most of the co-ops and the utilities across the America now have got their hubs like ERCOT, for example, that are controlling the grid from an overall standpoint, but you still have got switching, for example, that still has to be done manually. I build these things for a living, and I promise you there's still times where someone physically has to go to the substation to take a line out because it's not an auto switch. They can't pull up that substation and push a button on a computer from Austin and open that switch. Someone physically still has to go there. So the technology is there. I think a lot of the utilities lack the funding to prioritize some of that, to make that, to utilize some of that technology the way maybe they should. And then when they get funding, there's so many other things they need to spend that money on that monetization sometimes gets pushed to the side, or it's like, hey, we'll get to that when we maintenance that substation next time, instead of, hey, let's make a work order just to go put in these switchgear or put in these motor operators on the switches. But again, I digress. That's more of an opinion at that point.
Yeah, I understand that. In Texas, we the governor said we have it under control and we're just going to do more generation, more production as we move forward.
Yeah.
Now, I'm sure every state is not like that. I mean, this is one huge state. There are smaller states, like Louisiana and smaller states. And my question is what's the variability in growth for the need for labor? If we have a Pearl Harbor, for example, in electricity, can we have linemen come from all over the country, much like we do with forest fires and we do with hurricanes, to help out to build? If it's all built out in a smaller state, what's the cooperation between labor? Do you draw on other states when you have to build different kinds of capacity?
So I'll answer your first question first on the integration of AI is paramount. So we need to be utilizing AI to learn, to understand what systems need to be upgraded first, to understand where to incorporate the upgrades and the changes. So we're doing that as best that we can, and we're utilizing those tools to better streamline. Now, people like myself, and I think the next question there is talking about how we come and bring those resources. So, for example, my territory is New Mexico to Florida up to Virginia back to Wyoming. That is what I personally cover with my hundreds of men that report directly or indirectly to me. The way that I manage that is by moving them across states. So their home state may be Louisiana, for example, but the project they're working on may be in Texas or maybe in South Carolina, where I'm at today. So we use those resources across state lines on a normal basis. That's kind of standard operating procedure on the transmission systems. Substation is pretty much the same. They travel a little less. And it has to do with workload, has to do with how many projects are in a regional basis. But distribution, I think, is more where you're talking about there, where those guys become very regionalized, and a lineman can literally be born into the project or born into the industry, and they can live their entire career in the same county as they started it, or the same parish, definitely the same state. Those, just like transmission at that point, once you have a storm or you have an emergency response need, those linemen come from all across the United States. We do have some people we do bring in from Canada. We've even got some Australian companies that have started coming in, but we still don't see a lot of companies out of Mexico. Mixed feelings on why that is. I think there's probably just logistical problems more, but we could. And I think that's maybe what Mr. King was talking about a moment ago, is that, again, in the 80s and 90s, we had a system to where we could bring in linemen from other places. We could bring them here on visas. They had annual renewals, and they could actually stay here as long as they're working in good standing. My old boss, Johnny Priest, would, it was before I started in 98, but he would give me examples of, this is what we used to do, this is what we need to get back to. And he helped me try to start that conversation multiple times when I was on the IEEE board. I was having to go to Washington about every quarter to speak, and trying my best to find the right person to bring that up to with no success. I think we could do something like that again. I think that we could use the map that was laid out ahead of us and that was done successfully before. I think that we could, improve some things, work on some things, but the unfortunate portion to it is that when I got all those rejections, it was always for some political matter. It was always for someone somewhere has got a reason why there's a visa problem. And now, I'm not a visa expert by any stretch of the imagination. But the way they would explain it to me is that what we used to be able to do, we can't do anymore. And those were the parts that confused me, because I was like, if the need is there, I understand we have rules and regulations, we have checks and balances, but if something makes sense, let's call an audible. Let's work through a solution. Let's just not say, oh, there's a rule that says no, and just walk away from it.
Let me ask you a clarifying question. What do you do? Do you build new line, or do you maintain old line? You keep several
Both.
times. Well, you both. Okay, so you're both a constructor and an operator of transmission systems.
Yes.
How many miles of transmission do you operate?
So I manage between all of my clients, at least, because I know Dominion's got 5,000, Santee Cooper's got like 6,000. Between the rest of the clients, I'd say a couple 10, 20,000 miles.
That's very interesting. What about conductors or connectors? Conductors, I think, is the term of art. We're seeing a lot of companies offering carbon fiber cores to their conductors, which reduces the weight, eliminates the sag, all that. Are you deploying a lot of new technology wire, or is it still the old wire with a steel core and or everything that goes with that?
Most of them are still the steel core. It's usually done because of price. We do what some of the specialty fiber or specialty conductors, the 3M, the other companies escaping me right off the top of my head, but they've got a trapezoid cable. CTC, thank you.
Yeah.
Correct. So we are implementing those when we can, but where we implement those the most is when I've got a corridor or a right of way that is existing, and it's already double circuit, and or they want to make sure that they can continue to get the same or better ampacity out of the same system. If you don't want to tear down the towers and completely rebuild everything, what you can do is you can just simply reconductor that stretch of line. You can actually use that newer, we'll call it conductor, because it's lighter, more ampacity, larger size, and sometimes over the same size, and you can get more ampacity out of the exact same line. The problem is that most of the time, once they're going to spend that kind of money to do the labor in that area, you might as well go ahead and change the structures and everything else while we're in there.
In operating lines, has surveillance and things like that gotten easier and less people intensive? For example, drones and remote detection.
100%. We have, and I mean, everything used to be done via helicopter. Now we've got, and not just one or two, we have dozens of drone companies nowadays that all want to be a part of it. And the drones, I mean, no offense to helicopters, but the planes, but the drones are actually much more convenient. You can start and hit a section of line almost when you want to. There's not a whole lot of scheduling that is required anymore. I can take my time and I can actually zoom in all the way around a structure. I can identify, look at the connectors, go back where theoretically you can with a helicopter, but it's just not to the expertise that we can get, or the preciseness that we can get out of these drones now. So
I was just down in Georgia at a plantation where they were inventorying trees with drones, not only counting the trees, but getting an inventory of the mass of the tree, when it could be harvested, whether it was dead, whether it was a fire. Extraordinary capacity that drones have brought to tree surveillance. So I'm sure it's true. What when you look for a lineman, young people looking for work, and this sounds like an attractive job, what do they need? Do they have to be physically very fit? Do they have to have skills in math? Do they have to be adept in handling tools? Or can they be taught everything?
And nowadays they can be taught everything. It used to be.
You mean Johnny and I could get gainful employment yet?
I could do that. You know, my grandfather was a lineman for the Louisiana Power and Light Company in Monroe.
There you go.
West Monroe, Louisiana. Yeah.
My father strung quite a bit of wire across Africa.
Yeah. You know, Clint, my question, let's get a big picture here. You're a regulated industry, right? So we've talked about the fact that we still have to use human beings still have to hit levers and stuff.
Yes.
If you were, I want to do a little role playing for me now.
Okay.
If you were a private enterprise, all of the money that you have and the billions that we gave to California did not work out. We know that, right? But if you were a private enterprise, you were president and CEO of Clint's private enterprise, what would you do to get by the regulation? In other words, a regulated industry is tough, especially industry that has to change at 40,000 feet. We cannot be without electricity.
Right.
What would you do? What technology would you add that we have? This is your own private enterprise, and you're going to make it the best in the world. No regulation. What would you do?
Yeah, I think the easiest pieces to it is that we could streamline the interconnections. We could streamline what we wanted to put on the system. And right now we've got essentially you get put into queue, or the doom clock, if you will, where if you want your project to come out and you've got all these checks and you've got to go all these hoops that you need to jump through. If I could, if it was mine to control, or if I had my own state and then in my state I got to do what I wanted in, an integration of diversity between what types of generation. When I worked at Black and Beach was successful in putting in what we call combination units, where it was part solar, part wind, all in the same farm. I think that if we stop being so monolithic in the way we looked at generation, and then didn't honestly kind of hold it hostage once it was built and or made it wait so long, we could answer a lot of these questions and a lot of these concerns much quicker. The idea of microgrids in themselves help with different loads. They help balance the sine wave. They help balance what's going on in small areas. The batteries just don't have the extra money to go with them, or the weight to go with that. So you could identify projects, and then you could pair them with projects that make sense electrically instead of make sense dollar wise, or that makes sense regulatory wise. And you could actually just let the science help each other. Wind picks up at night, solar picks up during the day. There's no reason you don't put these two things together and let them have a natural gas plant next to them that then balances the load. But instead, we want to treat these like three different types, and we want to make sure that they almost were fighting for the same plot of land instead of utilizing them correctly. And that's the part I think I would change right out of the gate.
You're talking about, for an old dog like me, where computers were 60 years ago. Everybody was out doing their own thing. So let me give you a scenario. Would you like for all of the grids to be put together on a platform so that we can know where every piece of electricity is, so that Texas could share with New England, New England could share with California? If there's a storm, then we can switch stuff just automatically, just like we do with computers, with software. Do you 100%. Like that idea?
The idea is solid in itself. The science behind it and the need behind it, I think, are paramount. The problem that I keep being told is it's more of a security problem, and that by having the systems in the WAPAs and the ERCOTs that we have, it gives an extra layer of protection that no one can penetrate. And that if we did make it all one system, we did make it all one grid, then our vulnerability would be exponentially higher than what it is currently. Right now, if something happened, it would be locked into that grid or to that ERCOT or to that WAPO or so on and so forth. I don't have all of them memorized off the top of my head, but the truth behind that, or whether that's a political biased opinion, that part I don't know.
As far as I know, Clint, the east and west grids are interconnected, not as profoundly as people would like, but they are. ERCOT, of course, is separate, and that's more of a political decision or a cultural decision, even than it is an electrical decision. I'm so glad you're on this program, because we don't have a lot of people who actually have hands-on experience in the field. We have a lot of people who have opinions about what's happening in the field. So it is a rare delight to have somebody who actually knows what happens in the field. Apart from labor shortages, what is your next impediment?
Oh, the sharing of resources, the sharing of technologies across. We still have clients that are decades behind other clients. So you're having to not only learn systems themselves in order to teach a lineman how to be a lineman, but the next thing you've got to do is that, because again, I cross state lines on a regular basis. I've got 4 dozen clients. It's almost like there's 2 dozen ways of 2 dozen systems for those 4 dozen clients, and that becomes the next kind of gotcha. It definitely causes things to not be as efficient as they could be, because you have to stop someone and then retrain them on, hey, look, no, that's not, yes, the way you're about to do that is correct, but Entergy does it this way, or AEP does it this way. So you have to then all of a sudden retrain someone who's already been through 4 to 8 years of training, because this particular client likes doing it their way, or they like their system to be a certain way. So that definitely there's definitely efficiencies to be found. There's definitely ways that we could, if we could come to one standard, it would absolutely help everybody.
That's very interesting, because with nearly 3,000 utilities, almost 1,000 rural electric co-ops, about 2,000 municipals, plus the investor-owned ones, which are the ones we always hear about. That is an incredible. There is nothing else in the country that is so splintered as the production of electricity. It's insane if you look at 3,000 utilities. It's just under, it's not quite 3,000, it's very close. And there's no move to I've asked, and particularly in the public power sector and the rural electrics and the municipals, nobody wants to change anything. They certainly don't want economies of scale. They don't want. I used to live in a rather prosperous area of Virginia in the Hunt country, and we had a rural electric, and rather big one, Novec, which is just a distributor. They don't generate, they're purely a distributor. And I would say to my neighbors, all of whom were great capitalists, why don't we sell Novec? We don't need Novec. We should sell it. Oh, we can't do that. That's ours. The sense of local possession of these utilities is enormous.
Oh, yes.
And it's quite an interesting phenomenon, because essentially with their public power, they're on the socialist side of the ledger rather than the capitalist side of the ledger. Anyway, I find it interesting. I've taken too much time. Johnny.
No, this is fine. And Clint, we have had some interesting guests about as Lou Ellen would say, there are lots of opinions. But one of the most interesting guests was a lady from West Texas, and she talked about local generation. She talked about her town getting completely off of the grid. And I'm from southern Louisiana, where everything was independent at one time. All the farmers had their own independence in terms of electricity. Do you see any kind of movement? Let's take Texas, a state like Texas that has cities and from Lukenbach, Texas to wherever have you. Do you have any conversations at all about cities or towns getting off of the main grid and going back to the generation where they're independent of the main grid and they have their own production on their generation for the town
We
and
do.
nobody else? I mean, what kind of conversations are you hearing around that talk?
A lot of it is about what is the availability, what is the options, and we get we've had questions come to. They've started as small as buildings themselves, just wanting that building wanting to be off the grid, up to neighborhoods, new developments that have come in that wanted to have a solar farm slash wind farm, wanting to know about how much they would have to take off of the grid. Can they be completely remote? And working through those scenarios with them, because in a perfect combination farm, for example, between wind and solar, you still only have about 80% reliability. And as you'll know, Americans not having 99% reliability tends to freak them out. So they always want to know, okay, well, even if we were able to do this on a perfect scenario, how do we bridge that gap, or what's the backup? So that's when you, of course, have conversations about, well, you would have to have the grid, or you would have to have some access to whatever your, ERCOT or whoever. That's usually where the conversations tend to fall off, because if they can't completely be remote, or can't be completely off the grid, or many of them, when they see the price tag, they tend to change their minds fairly quickly. We had a smaller city, it was in Oklahoma, it wasn't in Texas, that they had requested what the options would be, sat down with their mayor, had lots of conversations about what the town's usage was, what kind of power consumption they were running, what kind of generation options. There was a lot of wind credits for Oklahoma, so he was hoping to maximize on that. And what actually got them, believe it or not, was the price tag plus the lead times. They thought this was something that they could do in 12 months. And when I showed them that, well, no, the transformer, the GSU, has a 13-month lead time after engineering is over with, we're talking 2 years, 3 years to get this whole thing built. That it became non-viable to them, because it didn't meet the timelines that they were looking for.
Yeah. Well, in that relation, Clint, let's talk about data centers. I think the state of Texas, they want 180 gigawatts.
Right.
Not 80 gigawatts. That's as you know what the legislature is talking about. And we also know that power centers are real. I mean, data centers are real.
Oh,
We also know that when I plug up my car, it's like, it's like taking a whole house to do that, right? And so if we look forward, and I want to talk about the relationship between economic development and the future of economic development and kind of what you do. Uh, how are data centers generating their electricity? Is it through the traditional way of of oil and gas? What's going on
many of
there?
them are.
Because they are real, and I also think that the data centers are, at one time, Berkshire Air Force Airport was a base here, a SAC base, and underneath Berkshire Air Force, by the way, is a whole nother city, because that's where we had our nuclear airplanes, right? So I think that data centers are becoming like that. But tell me about data centers, requirements of electricity, what it does for your business, because what it does for your business, it will also be what it does for Amazon in the future, what it does for the Lexus dealership in the future, and what it does for the local toy shop. How do you see how do you see the power for data centers and what they require coming on?
So many of the conversations we're having with them are about tapping into the grid itself. They want to know where it is best to get onto the grid, and they want to know best where could they get generation themselves. A lot of what I do is help them find the correct spots and correct, quote unquote. But also talk to them through what generation that they would actually like to see. Many of them have very unrealistic goals on how they would achieve that. They think that well, they'll, the local utility or that generation they'll just meet my needs, and unfortunately for them, that is not the case most times. We have spoke to many of them about SMRs and the availability of SMRs and how they could basically have their own little nuke facilities while they wait for traditional generation to be built for them. Some have become interested in that, some have not. Some of them are much more worried about the waste and the ramifications of having a small nuclear device on their facility or on their grounds of the facility. Many of them would rather just wait for natural gas. I mean, a natural gas plant can be built in 18 months or less with some permitting, as long as permitting goes smoothly. And when you show them that, you show them the price tag of a natural gas facility versus a couple of SMRs, they like one option or the other. But what we've been trying to explain to them is that if you go with SMRs, for example, yes, your first projects it's going to take that 18 months to 2 years to get it there, to get it running. But at the same time, if you've got the capital investment, then you can also build a gas facility. And then say you start the gas facility at the 1 year mark. So that by the time the SMRs are up and running, your data center is up and running, you could then transition your power supply from the SMR to the natural gas plant. But then you could actually, those SMRs are mobile, but you could actually pick them up. And now it's an owned asset. You could move it to the next data center that you're either already in progress of building or it's already been built or it's going to be built. And you can actually start to use that asset on multiple projects in the future. Many of them had not thought of that. Many of them had believed that that could potentially be viable. But on the flip side to it, most of these developers we're talking to, they're kind of one and done people where they're just going to build this data center, or they're going to build this one, maybe the next one. They're not really caring about, hey, look, this idea could continue to be productive for you for 10 years. So we're giving some of them ideas that it's kind of falling on deaf ears because they're trying to get rich today. They're not really overly concerned about 6 or 7 years from now. So
this is very interesting, Clint. What I have found is that the big data center companies behind them, Google's, etc., are not only keen to get their hands on a lot of electricity, they want to appear virtuous. They want to signal virtue. So they want to buy up all the available renewable, and they really want to avoid coal or any of the traditional fossil fuels, coal, oil very occasionally. And that's kind of interesting. Also, I think, and I'm interested in your view of this, that while they think they can come into the electric world, when they get into it, they'll find themselves facing all the frustrations and limitations and challenges that any utility faces.
Yes.
We tend to look on these companies as though they're magical because they've made a lot of money as high-tech companies, that somehow they can do everything, which is something we do in America. When somebody's good at one thing, we assume they'll be good at another. If they're good at painting, we think they can play the cello. They can't. And that's an interesting phenomenon we're facing. We're seeing it in the national level with the expectation that Elon Musk could run the government, but he found it quite challenging, although he's a very accomplished fellow.
You're exactly right, Llewellyn. And on that post, on that point, Elon registered his company as a provider of electricity in Texas, and not as an automotive company. Clint, were you aware of that?
I have actually heard that before, yes, sir.
So Clint,
I think the plan there is to use the batteries as in the Teslas as a source of electricity.
Absolutely,
which is an unproved concept. whether
And
people
also to take every household like mine and connect that battery to the car so that he could have complete control of complete market. So what we're talking about here, Clint, is for the first time is some kind of competition, not of the source, right? As Llewellyn said, they all want to be crystal clear, and when they get it from, and appear as doing great things. But have you guys had discussions about the evolution of batteries, what it means? What Andre Cavallo's F-150 truck meant that he was in love with. So as you guys have your conversations, and as the household, that is, what's happening behind, right? What we call the Internet of Things, right? All of those things are having an impact on what you do. So I guess my question is, in your discussion, has it become more universalistic as we move, or are we going to move to batteries? Remember that we had battery cars back in the 1800s, right? Remember that when I grew up, all of the street cars in New Orleans were electricity. I mean, they had the big rails right on top of them, and in Austin, Texas. And we also know that the electric cars were seen as more efficient, and not to mention the fact that we had an electric grid in California with the little red cars that took people all over the valley, and General Motors make sure that they got rid of them. Did you see any of that kind of competition going on? And as you discussed the needs for electricity across the states that you provide?
So not so much, I don't get into those discussions. What I have got into is an understanding that you don't have to have a traditional battery to have a battery.
Okay.
And that has become more of an interesting topic here lately. For example, you can utilize, so I mean, a battery is a storage of energy. We have started to have conversations, and we have gotten some successful projects now. I can't speak to their names, but I can tell you that you can seal a salt mine, and you can pressurize the only entrance to a salt mine, and you can utilize the extra energy throughout a day to then pump air pressure down into that salt mine. And then when the energy itself is no longer needed, or the excess is over with, you can pop that valve, if you will, in simple terms, and you can use that now pressure to then create energy again through generation. It's still technically a battery, though it's not more of the traditional what we're used to having the conversations about. That stored energy, that is what's raising a lot of conversations and a lot of trying to get people to think of, instead of trying to build a better mousetrap on, is it an ion battery or is it a lithium battery or so on and so forth, is what other kind of things can you store energy in that we're no longer utilizing? That salt mine, for example, was one instance where it was being successful. I think that's where we're going to see a lot more. We're going to see a lot more of these places that are being decommissioned, and we're getting away from that technology, but somebody can utilize that site and or the byproduct as a new type of storage.
Very, very interesting. Like, we know that the Baghdad battery is 4,000 years old, right? From the ancient world. So you know what, as we move forward, and as I think about integrating the research with what we know, and you just mentioned, moving away from old technology to new technology. I guess if I were to ask you, what's the distribution of generation we can live on in America? How much wind, solar, traditional oil and gas? I'm from a state that outlawed, right, the possibility of getting away from oil and gas for electricity. How do you see the blend, if you will, if you could hit a button? How much do we need? How much solar? Sun is going to go down. How much wind? We have lots of wind in West Texas, but that also goes down. How do you see the blend of the material that we need? And Llewellyn likes to talk about other kinds of energy that's unstable, right? How do you see the blend of is it nuclear? How do you see the blend of it?
I think eventually we stop being scared of nuclear and let it. You don't have to just use uranium, and I think that when people start to remember that there were two different types of sources to get that nuclear reaction. The other one actually eats itself. And that's a whole different science topic, and we can nerd out on that on a different conversation. But I do believe that people stop having the fear of nuclear, and nuclear is what's going to actually replace a lot of the oil and gas. I think that we can produce as much wind as we can right now, but I see, me personally, I see that capping out. I think that we're only going to get so large with the turbines that energy is only going to become so efficient. We can only change out the older farms that are, with their smaller KW units, and put the 3.6s up and the 4.2s up. But once you get to these new 6.0s and a little larger, quite frankly, you're kind of topped out. So I think wind will find itself to have a limit. Solar, obviously, we've got a lot of land. We can put solar anywhere. I saw the indication for solar roads a while back, putting solar walls on buildings. All of those are great ideas. But each one has limitations, and each one is a petroleum byproduct. Each one's got plastics. Each one's got different pieces and parts that go right back to oil and gas, and a need for oil and gas to then make these things viable. So I feel like someone is going to get to the point to where they're going to get over their fear of nuclear. They're going to realize that that's probably the cleanest way that we can produce. If you would change uranium for the other alternatives, then you won't have nearly the waste that you currently have. And I think that people will finally start to move in the right direction.
Clint, a good friend of mine, John Goodenough, he won the Nobel Prize, University of Texas chemistry professor.
Okay.
And I guess 2019, I'm guessing, for the development of the lithium batteries, right?
Mhm.
I wonder what's going on in China with that kind of development, because what's going on in the laboratory. And he won the Nobel Prize in '92, I might add. What a scholar, right? He won in '92. Is there any interaction with what you guys are doing and what's going on in other parts of the world, and the science in other parts of the world? I look at the BYU cars in China that's much more efficient than our cars, our electric cars here. And I was a professor in China at the University of Beijing for summers. Did you share in any of that scientific knowledge about the impact of batteries, or the impact of new batteries, and those kind of things, or is it just an American kind of science that we're depending on?
So in my world, remember, I'm just a lineman. So I'm more stuck on just the American science.
Oh, by the way, I sent you that song. I am a lineman for the
Thank you.
county. I cannot believe you don't know that song. I'm
No,
impressed.
thank you.
Okay.
But again, I mean, I focus more on the technologies that we're implementing now. What can be more efficient here? I'm not on the R&D side. I don't do a lot of the research. I stay fairly busy just building what those options are. The study and the interesting parts that I find they're more for myself. They're more for me and my education, and trying to then educate my clients on, hey, have you thought of this? Hey, have you looked at that? Most of them, kind of like what we were talking about earlier, are stuck in their ways, and getting them to see the new invention of the mousetrap. Most of them don't care.
I would like to endorse what you said about nuclear. I've been advocating nuclear for more than 50 years, and now it really is in sight. Unfortunately, it may be its own competitor, because for the first time, fusion is in sight. It's not here, but one company is promising a operational, they don't like to call them reactors because they don't have a reaction fusion, but a fusion appliance as early as 2032, which of course will be rather revolutionary. But I'm so with you, and I'm so glad you mentioned nuclear is the only way to make the volume of electricity with the least impact on the environment. If I can take a moment, I was once sitting looking at the Seabrook nuclear plant with some members of my wife's family, and a very smart young woman said, "We've got to close that down, Llewellyn." I said, "What are we going to put here?" I happen to know it's 1,250 megawatt plant. And Seabrook 1, Seabrook 2 is never finished. And she said, well, we'll put in windmills. And at that time, the average one was about 2 megawatts, 1.5 to 2. So I said, well, 1,250, you're going to have a lot of windmills here and a gas plant. And she was a smart girl. She started doing the math. She said, "Are you sure you're right?" She said, "Oh, I thought only 2 or 3 of them would do." Once the public realizes the energy density is so high in nuclear and so low in almost everything else, by comparison, including coal and gas, there shouldn't be any controversy about it. It's the logical thing, and it's something we control. It's science. You don't have to import anything to do it. Where is your company headquartered?
New Jersey.
And is it a publicly traded or is it privately held?
Private.
Okay, and what is its formal name if people want to look it up?
So it's Ferreira Construction.
Ferreira Construction, fascinating. And do you operate overseas or only domestically?
Domestic, sir.
Mm-hmm.
Very interesting. How long has it been going?
Since 1988.
Grand. And you contract 2 utilities, both to construct equipment for them and then to operate it.
That's right. Mm-hmm.
Is that a new development? I've never heard of it, where the constructor becomes the operator. Is that a new trend, or is this unique to your operation?
No, so there's multiple companies that do it now. Most of them would either focus on operations or maintenance and or construction. You've got a few dozen companies now that touch all the gambits.
And going back to linemen and the shortage of linemen, what can a journeyman lineman expect to earn?
Oh, so on a normal scale, on the non-union side, Class A makes between $35 to $50 an hour, which is typically anywhere from 130 to 200,000 a year.
I like non-union. You should be in Texas. I was a professor at Rutgers for 8 summers, and the taxes they took out of my check was wild because of the union. Even the faculty members were unionized. Well, as I look at the time,
be careful about this union thing, Johnny. I was president of the newspaper guild in Washington.
In Texas, we call it the student union.
And at one time, I was a member of the typographers union in New York. So be careful.
As I look at the time, we have we want to thank you, Clint, for coming.
Oh, yes.
And Llewellyn, we also outsource a lot of stuff in our military too. I mean, I just finished a big research paper on what we're outsourcing. So there's a lot of outsourcing going on because of the kind of talent that Clint's company can bring to the table. So I want to thank you, Clint, for coming on Digital Roundtable on behalf of Andrea. And thank you for really, really thinking about the problems that we think about. And as Llewellyn said, it's good to have somebody that's actually doing something on the program rather than complaining about it or having an opinion on everything. And
Happy to be here.
Our president of the United States who said, "I really want to fail. I don't know what failure is. I would just like to fail one time just to see what it feels like." So what we're saying is I mimic the president of the United States is that we do not want the electricity to fail. And whether it's in my house or I'm at a football game at Longhorn Stadium or Tiger Stadium, we wanted to come on. So Llewellyn, do you have anything else to?
I find this
Yes.
I find it very constructive, and I salute the fact that he is hands-on, that he actually builds things. He doesn't talk about building them. He doesn't say we should or we might or we could. He does it, and that's very, very encouraging. Thank you for coming on.
I would take us away
Thank you, sir. Thank
All
you.
my bags are packed. I'm ready to go. Standing here outside your door. I hate to wake you up and say goodbye. But the dawn is breaking, it's early morning. The taxi's waiting, blowing his horn. Thank you so much, Clint. And Clint, I want you to learn that song, I Am a Lineman for the County. I'll send it to you. And
Thank you.
let that be your theme song. Thank you so much.
Y'all have a
Okay.
good day.
Bye-bye.